Okay, now we're moving on to 6.4. 6.4 is rational expressions, equations, and functions, but specifically we're dealing with rational equations. So rational, remember, always means fraction, and so we're dealing with rational expressions that we're looking for the solution. So things with an equal sign in it that are also dealing with fractions. That was a little confusing. You're with me though. So I already did one example when I talked about 6.3, but let's do another example. X over 2 minus 1/4 equals 1/3. Well, this kind of looks a little bit confusing. I don't exactly know what to do. It would be great if I could make all of these whole numbers, just because that'd be easier. Doesn't mean it's better, it's just a little bit easier. So what I'm going to do is I'm going to determine what my least common multiple or my greatest common denominator is. So I'm going to look at 2, 4, and 3, and I recognize that that is 12. My common denominator is 12. So I'm going to take that and I'm going to multiply it by both sides. Okay? A lot of people forget to multiply it by the second side, so make sure that you multiply it by both sides. And then I just rewrite it. That's 12x over 2 minus 12 over 4 equals 12 over 3. Now I can reduce. 12 divided by 2, that's 6x minus 3 equals 4. Plus 3 plus 3. So I know that 6x equals 7 divided by 6 divided by 6, x equals 7/6. Okay, well that's not that bad at all. But this isn't the only problem that we have. There's tons of problems that are similar to this. And so let's talk about a couple more. So this is x minus 1 over x minus 5 equals 4 divided by x minus 5. Now, you'll remember in earlier chapters we talked about limitations on the domain, and that means numbers that we can't put in the bottom because then the bottom would become a 0, and if the denominator is a 0, then the fraction is undefined. So, what number could we not put in the bottom? Well, that's easy. X cannot equal 5 because 5 minus 5 would be 0, and then it's 4 over 0, and the whole world explodes. So, if x cannot equal 5, I'm just going to put that over here in my brain, and I'm going to continue solving. So what's my common denominator? Well, it's x minus 5. That's easy. I don't have to do any work for that. So I'm going to take x minus 5. I'm going to multiply it on both sides. Okay, so that's x minus 1, x minus 5, divided by x minus 5 equals 4 times x minus 5 divided by x minus 5. And now I can cancel. X minus 1 equals 4, plus 1, x equals 5. Done. But, if you remember, x cannot equal 5, and x equals 5. So what happens? There is no solution. Because the only solution that exists can't exist. Okay? Let's do another one. X plus 4 divided by 3x plus x plus 8 divided by 5x equals 2. So first I'm going to factor everything. Can't factor, can't factor, can't factor, can't factor, can't factor, so I'm done. Now I'm going to look at the denominator, and I'm going to ask myself, what is my common denominator? Well, I know that it needs a 3. I know that it needs an x. I know that it needs a 5. And I know that it needs an x, but I already have that. And this, of course, is just 1. It's an understood 1, and so I don't have to do anything with that. So my common denominator is 15x. So I'm going to take 15x and multiply it by both sides. So 15x times x plus 4. And you don't have to distribute at this point because you know if you did your common denominator right, you are about to start canceling some stuff out. Here you can multiply if you want, that's 30x. So, see you later x's, 15 divided by 3 is 5 times x plus 4 plus 3 times x plus 8 equals 30x. Now, I'm just going to distribute these. Pay careful attention to signs, especially if this is a negative. I'm going to add up my like terms, so that's 8x plus 44 equals 30x. Then I'm going to subtract 8x from both sides because I'm trying to get x by itself. 44 equals 22x, divide by 22, divide by 22, 2 equals x. Now, let's go back to the beginning. What was my limitation right here? X could not equal 0. So is 2 okay? Yes. And now let's plug it back into the original equation. 2 plus 4 divided by 3 times 2 plus 2 plus 8 divided by 5 times 2 equals 2. 6 over 6 plus 10 over 10 equals 1 plus 1 equals 2. Yes. So that's that. Now I've got 2 more examples just because I want to give you as much exposure to this as possible. But you can probably tell this is going a lot faster than 6-3. And that's because it's a little bit easier to visualize because you're really solving for something. And then you get to check and see if that's correct. So remember, my first step is to factor everything. So I'm just going to rewrite this. And then, what are my limitations? Can't be negative 5, can't be 5, can't be negative 5, can't be 5. Okay, so I'll put that in my brain. My common denominator has to have an x plus 5, needs to have an x minus 5, an x plus 5, and an x minus 5. So that's my common denominator. I'm just going to multiply it on the top of each one, okay? So 2 times x plus 5, x minus 5 divided by x plus 5, plus 1 times x minus 5, x plus 5 divided by x minus 5 equals 16 times x minus 5, x plus 5 divided by x plus 5, x minus 5. Now the fun part, you get to cancel stuff out. X plus 5s are gone, x minus 5s are gone, x plus 5s and x minus 5s are gone. So rewriting this, I have 2 times x minus 5 plus x plus 5 equals 16. 2x minus 10 plus x plus 5 equals 16. Add up my like terms, that's 3x minus 5 equals 16. Plus 5 plus 5, 3x equals 21, divided by 3, x equals 7. Now, to check, I'm going to say 2 over 7 plus 5 plus 1 over 7 minus 5 should equal 16 divided by 7 squared minus 25. So 2 over 12 plus 1 over 2 should equal 16 over 49 minus 25. So 2 over 12 plus 1 over 2 equals 16 over 24. Okay, let's find a common denominator between these, which actually we can just say that's 12. So this would become 6 over 12. 2 plus 6 is 8 over 12 equals 16 over 24. And just by looking at that, we can tell that 8 over 12 does equal 16 over 24, as this would reduce partially to this. So that means we got it right. Okay. This is the last one. 6 divided by a plus 1 equals a divided by a minus 1. All right. Now, can I factor anything? Nope, I can't factor anything. So what's my common denominator? My common denominator needs an a plus 1 and an a minus 1. So I'm going to rewrite this with this common denominator multiplied at the top of each fraction. And I know I'm doing this a little bit fast, but that's one of the reasons why I'm recording it. It's because you can play it 150 times if you want. So I've taken my common denominator and I multiplied the top of each side. It happens that there's only one fraction or one rational expression in each side, but if there are more than one, I'd multiply it by every single fraction. And then I'm going to cancel that out. I'm going to cancel that out. So I have 6 times a minus 1 equals a times a plus 1. 6a minus 6 equals a squared plus a. Now I want to get everything over to one side. Might as well move it this way because the a squared is positive here, which is good. So minus 6a plus 6 plus 6 has 0 equals a squared minus 5a plus 6. And then I'm just going to solve this the old school way. I know 2 times 3 equals 6. The signs are the same because this is positive, and the signs are both negative. And so a equals 3 or a equals 2. Now going back here, what were my limitations? A cannot equal -1 or 1. So both of these are okay. And I could of course plug them in to see 6 divided by 3 plus 1 is 6 over 4, which is the same as 3 over 2. If this was 3, that would be 3 divided by 3 minus 1, which is 3 over 2. So 3 checks out. And if we put 2 in, 6 divided by 2 plus 1 would be 6 divided by 3, which is 2. And then 2 divided by 2 minus 1, which is 2 divided by 1, which is also 2. So they both check out. So that is 6-4 at super crazy warp speed.